Okay, question 5, the estimation question. Before I start tackling the question, I'm just going to jot down the key information from the question. So I've got a sample of 3 is x bar. So I know that the sample mean, the expected value of the sample mean is equal to the population mean. I also know that the variance of the sample mean is equal to the variance of the population divided by n. So I'm jotting these results down before I start. These are likely to be useful in these questions. For y bar, the sample was 4, so E of y bar is still mu, but the variance of y bar is now sigma squared on 4. Okay, on to the question. Part A asks me to show that, in the first part, that mu1 hat is an unbiased estimate for mu. And the key thing with these is to realise what that means mathematically. So I need to be able to translate that into a mathematical statement. Show that the expected value of mu1 hat is equal to mu. And from there, I can start to build it up. So I know that the expected value of mu1 hat is equal to the expected value of just switching what the formula that was given. I can then use my results for E of ax plus or minus b of y to break that apart. I've already stated that E of x bar is mu and E of y bar is mu, so I can swap those results in there, and I can show that that is equal to mu, and therefore mu1 hat is unbiased as required. Now the key thing for these is actually the argument, so those steps I think make that process quite clear. So I'm including lots of steps to show my argument. Part 2, the same thing again, but for this time mu2 hat. Same step, substitute it in, break it apart, substitute what you've already said, and again we find out that it's equal to mu, so that mu2 hat is also unbiased as required. So that's part A done. Part B asks us to find the variance of mu1 hat. So, okay, let's set this up. I know now that I can also use my results for variance of ax plus or minus by. Remembering, of course, that the constant comes out as squared, and whether this is plus or minus, it's always plus. So I've got that result there. I jotted down at the start of the question that the variance of x bar was sigma squared on 3, and the variance of y bar sigma squared on 4, so I've got that. So now it's just a case of tidying up that little bit of arithmetic. I can factor out sigma squared, and I think if my arithmetic is okay, that comes out to be 4/27 of sigma squared. Part C, it then gives us the variance of mu2 hat and asks which one then should you use. But if you've got a choice of unbiased estimates, the better one is going to be the one with the smallest variance. It's going to be more accurate. And so I just need to compare this value with this value and see which is smallest. Well, I've got mu1 hat is smaller, 4/27 is smaller than a quarter. So this is smaller than the variance of mu2, therefore use mu1. And they'd be looking here for your answer with the reason for the 2 marks. And that actually means that it's more efficient, is the word that we use, so that you wouldn't necessarily need that to get the marks for that particular part of the question. So there's your solution to question 5.